my screen. So what is data science? So this is very fancy term where people are very uh, highly attracted uh, nowadays, and everybody wants to become a data scientist and they want to learn about data science. So why people are moving to data science? So what is a data science? So data science is a field. Most of the people think like it's a technology, which is not correct. Data science is a field which will have a group of or set of processes and systems are tools which will help to extract knowledge or insights from the raw data. So raw data means any kind of data which you receive. Nowadays, data is in various forms. Like we have like normal like structured data like rows and columns, which will be in the form of database tables, or it can be in the Excel files or CSV files. And we also now experiencing some semi-structured, quasi-structured, unstructured data also. Why? Because nowadays even image also people are considering as data, even video or document or voice. So every like unstructured data is also people are like trying to analyze. So as part of the data science activities, as a data scientist, I should be able to process any kind of data which will fall under these categories. So how can we do that? We need to go and use some set of statistical methodologies, also data mining, and predictive analytics, which is one of the area where data science is already emerged. We need to know what is predictive analytics and how to use it to discover the knowledge in the databases and then get some meaningful insights out of that. And that insights should help the customer to go and take some appropriate like decisions to improve their business. So data science is helping in that area. When I say like data, so data is nowadays coming in from many different sources. The motivation why people move to data science is the data was before 2010. You might have seen the most of the data was only structured data. People are only focusing on data in the form of tables, which is in rows and columns, and every company started centralizing their data by leveraging the databases. So as soon as we moved from 90s to 2000, when I say 2000 to 2010, most of the companies focused on ETL part, like how to extract the data, transform and load into the target data warehouses. So people started analyzing the data. So once after we moved to 2010 decade, the data growth became very high. Most of the data got generated after 2010, and that too within a span of 2 years. So you can imagine the petabytes of data got generated after 2010, especially in 11, 12, and 13. So most of the data got generated. The reason, there was a valid reason for that. Can someone tell me what is the reason for high data growth after 2010? Who will tell? Anyone? Whatever you know. What is the reason for high data growth after 2010 in the market? Any idea? Why the data was like data growth was very high after 2010? No idea? So you might have experienced after 2010, 11, and 12, there was a revolution in data due to the fact that social media got emerged. Facebook got invented. We got like many different social media applications got emerged after 2011 and 12. LinkedIn got invented. Facebook, and then after we got like Twitter, Instagram, WhatsApp, YouTube. So many applications got emerged, and slowly data started growing, and every company started growing their data. They were experiencing the data growth, and the reason behind that is you can see so many devices got also invented, and you can see so many devices, data devices started like generating data, and this data people started thinking about how to utilize this data. So after this data growth became very high, there are so many data companies also started. So every data company started and they started collecting the data from different sectors here, like government sectors, medical, internet, and retail, financial, and most of these sectors started generating data, and every company started collecting this data and they started aggregating that data. Once after data has been aggregated by applying some methods, and this data got a final format, and that data people companies use it to sell to the customers. There used to be data buyers. Even till now, people buy the data. Example, telecom companies or financial institutions, banks, credit card companies, the loan companies. So all these companies buy the customer data, and then using that data, they will reach out every customer. You might have get so many calls, right? Credit card calls and loan calls. So how do they have your number? Because they buy the customer database from these companies, and these companies will sell the data, and as soon as they receive the data, they will try to reach out every customer, and they will start marketing their products. So here data is one of the oil. So data is basically is very important for any company, and the companies are ready to buy even data from other companies who are producing this data. So data devices became one of the main reason for generating data, and the slowly that data growth increased, and from you can see, imagine this in the 90s, people were experiencing like terabytes, and that too very occasionally, because most of the data was only structured data, and data warehouse also started during 90s only. As soon as we moved to 2000s, we got MS Office and Acrobat Reader, and some of the digital asset management came into the market. Slowly, data moved from terabytes to petabytes. Once we moved to 2010, as we discussed just now, social media companies got emerged, and data has been moved from petabytes to exabytes also. So 2010 itself, you see, we experienced exabytes. Now you can imagine in 2000, after 15 years, how much data got generated as of now. So data is growing, and the data slowly became a big data also. So most of the companies who generate this data, they also started centralizing their data by using some big data tools as well. And before, data was not that much used. People were leveraging data warehouse to store the data, which is called enterprise data warehouse. And this data, whatever you see here, this data people use it to leverage for dashboard reports and data science activities also. But the sources for this enterprise data warehouse is normal Excel and CSV files and database tables. This is the existing analytical architecture. As soon as we move to big data, then the sources got increased, the size got increased, the speed got increased. So high volume, high like velocity, high different varieties. We got so many varieties of data. If you heard about semi-structured data like JSON files or Parquet files or XML files, all these fall under semi-structured data, and this semi-structured data got generated after 2012 only, because most of the big data tools got generated this kind of data. So companies started using the semi-structured data also as part of their data journey. So everybody need to know how to load this semi-structured data also in any big data project, not only structured data like CSV. So as soon as data has been generated and pushed into enterprise data warehouse, there are people who will leverage this data by building dashboards or reports, or also some teams use for machine learning and data science also. So as a data scientist, I need data from the data engineer. That too, I need a right amount of data. I need a right data which will help me to analyze this data. If I don't get the right data, my analysis will go wrong. So as a data scientist, I should ensure that whatever the data I received is the right data from the data engineering team. And most of the drivers of big data which we discussed is medical diagnostic images also became one of the reason for high data growth. Photos and videos which people upload into the internet using Facebook, Twitter, and other like social media tools. Also, one of the main reason for high data growth, which impacted and which is the driver of big data. And video surveillance companies. So video surveillance companies also, so many companies got emerged to perform video analytics. So what they do as part of video analytics, if you go and see some of the companies, they do go and try to monitor the videos and they tag suspicious people also. So that will happen with especially with a criminal department. And mobile devices also generating text messages, phone calls, and application usage. All these are also became one of the reason for big data. And if you go and see some of the like countries have like smart electric meters also nowadays. They also generate some data. So most of the non-traditional ID devices like credit card readers, GPS trackers, all these will generate huge amount of data. So all these, whatever you see, are the drivers of big data. And as soon as big data is ready, people started analyzing that. Then only data science got a fame. If you see, most of the data science projects got started after 2012 only. Before that, there was data science, but very, very limited. There were no even data scientists also before 2010. People were there. People used to call them as statistical programmers. They are not data scientists. A data scientist is a statistician with knowledge of machine learning also and programming. But a statistician may not have programming knowledge. So a data scientist will have the statistics plus also programming as well. Both they will have. So that is where a data scientist became very, very famous after 2012 onwards. And if you see the data varieties also, as we discussed, we have structured, semi-structured, quasi-structured, and unstructured. These are the four varieties of data where a data scientist need to analyze any kind of this format and should be able to extract some meaningful insights out of all these four types. If I receive quasi-structured, I should do some analysis. If I receive unstructured data like video, I should be able to analyze. If I receive semi-structured data like JSON, I should be able to analyze. If I receive a CSV file or database table which is structured, I should be able to analyze. So I should analyze any kind of data which I received from the like respective teams. So structured data is nothing but RDBMS data, CSV files, Excel files, all will fall under structured data, which is in the form of rows and columns. When I say semi-structured data, you might have heard about JSON files or Parquet files or XML files. All these type of files will fall under semi-structured data. Semi-structured data is nothing but which does not have fully structured. It is a partially structured data. So sometimes you may need to analyze the semi-structured data also. If you go to the next type, which is quasi-structured data, you might have heard about this particular data, but you are not 100% sure that that data is quasi-structured. If you go to Amazon website, how many times you bought any product and you got some recommendations? If I ask you, how many times you got recommendation when you buy any product? If I ask you, anyone, did any time you got any recommendations when you are going to pay the money before? Yes or no? Are you getting what is my question? Did any time you encountered any recommendations to buy? Why can't you buy these products together? Such kind of recommendation, did any time you received? My question. Yes or no? Shreya or Bhanu or Chandana. Did any time you encountered the recommendations? By any chance? Shreya? Yes or no? Or Bhanu or Chandana? These recommendations, how you got only those recommendations? You need to think about it. The recommendations what you receive when you buy any product, that is because there will be a recommendation engine which will be running to provide meaningful recommendations on what you interested. So the recommendation engine algorithm will do that. So that algorithm is a part of data science or machine learning. So quasi-structured data is nothing but the data which every e-commerce company, for example, will track about their customers. Every customer, when you visit any website, you will try to visit multiple pages. You go and see which products you are interested. So most of the activities what you perform, those activities will be tracked by that particular company with a type of data called clickstream data. So which is also fall under quasi-structured data. So assume you visited 4 pages, so they will count it. And you visited a page which contains books, or someone visited a page with electronic goods. So your activities, each and every step will be tracked in a clickstream file. And later they will use this clickstream file and they will try to extract what pages you visited, what products you selected. So according to the products you selected, you will get some recommendations. This will happen with everyone. So Amazon is an example. There are so many companies do that. Even Udemy website also try to perform the cross-selling of their courses. When you buy any course, they will try to attach few more courses so that you can buy them. If you really require it, you will buy it. If not, you will skip them. But the recommendations will come. Is it correct or not? Every company will do this. Udemy, Udacity, every e-commerce like e-commerce and educational institutes, they are doing this nowadays. So quasi-structured data also very important data for any project. And finally, unstructured data, which is like documents, PDFs, images, videos, all will fall under unstructured data. So if I am a data scientist, if I receive any image and someone asking me to perform image recognition, I should be able to do that. If I receive a video and you got a requirement to tag some suspicious people in that, you do that. If you receive any PDF document and you asked to pull some meaningful column from that PDF document, that also fall under machine learning only. But the algorithms will vary. But at the end of the day, you do the same machine learning and AI or data science, whatever it is. So all the 4 types of data people are using to analyze, and they want to generate the meaningful insights from any kind of data. If I say image, I will try to match the image with another image and see whether that image is the right person image. Or video, I will go and use video analytics. If you go and see, most of the companies nowadays, they are tracking the speed of the vehicles. So when they track your vehicle, and if you crosses that particular limit, the speed camera will try to click a photograph of your vehicle's like a number, and that will be tracked according to the vehicle number. Your address will be captured and you will get a notification on what is the fine and what that particular traffic department is looking for. So unstructured data also became very important for every company. And apart from that, when I go back and say, people sometimes also get confused about data science, like business intelligence and data science. See, business intelligence is nothing but where you go and use the business intelligence to build some kind of analysis which was happened in the past. So what was happened last quarter? How many number of units got sold last week? And where is the problem with that product? When that product is going out of stock? It went out of stock. And what is the reason for that? So all this can be answered using a business intelligence dashboard. So Power BI I can use. I do not need any kind of data science or machine learning for business, like for explaining the past what has happened. So data science is more than business intelligence, which is a artificial intelligence where you go and try to answer what could happen, which emissions will go down in the manufacturing plant, and what action we should go and take on that particular mission. And if the mission went down, which products are the reason for the mission to go down? What is the reason the mission went down? So all these questions will be answered by leveraging data science or machine learning, both. So data science is a artificial intelligence, whereas business intelligence will give you a dashboard to build that. And I can compare last month and current month sales by using a dashboard, and I can create a trend analysis. But data science will help you to predict what are the sales next week. But business intelligence can answer only what are the sales for current week and compare it past week. So this particular data science is the one which we need to focus more. What we need to go and do to predict the future. And the analytics which we discussed about, data analytics also divided into three types. First one is descriptive analytics, second one predictive analytics, third one prescriptive analytics. So what is descriptive? Whatever we discussed just now, business intelligence, where you are going to describe what was happened in the past. For that, what we do, we go and collect all the historical data and we'll try to answer what was happened in the past. For that, I can use a dashboard which is sufficient. I do not need any machine learning or data science for that. When we move to predictive analytics, they are predicting something in future. So this will answer the question like what could happen in future. So to achieve this, we need a machine learning knowledge and forecasting method and statistical algorithms to understand the future and answer what could happen in the future, what could be the sales next week, and which missions will go down next week, and who are the loan defaulters, customers of which are who are loan defaulters, and what is the price of a particular product, and which flights will be delayed next week. So I can go and predict the future here by using the predictive analytics. And assume that the scenario is I want to go and I have a manufacturing plant where I have hundreds of machines that are running and which are producing the manufacturing products. Suddenly, out of 100 machines, 2 machines went down. And what happens if the machines will go down? Automatically, your business will be impacted. Your delivery will be delayed. So production will be slow. So I can go and use descriptive analytics and answer which machines went down, what was the reason last week. I can only do that. I can do that using a dashboard also. When I go and use predictive analytics, that predictive analytics will help me to predict which machines will go down next week according to the past experience. Assume that the 2 machines went down because there was a defect in the product. So after I identified that there is a defect in the product, that is the reason the machine went down, we will immediately notify the vendor to come and replace those defective products. But whatever the process you are using here is a manual process to reach out the vendor. But what if my system itself can go and send the notification to the vendor that these 2 machines went down and come and replace? That is called prescriptive analytics. So prescriptive analytics will help you to answer what should we do also, what action to be taken. How many people heard about chatbots here? Whenever you visit any website nowadays, chatbot is very common. A bot will come and respond you. Even that will fall under prescriptive analytics because bot will learn from the experience and it will try to answer accordingly. So prescriptive analytics is the one which is running in the market with the help of deep learning and artificial intelligence. So as a data scientist, I should know what is descriptive analytics, predictive analytics, and prescriptive analytics also. So types of analytics is very, very important to understand because as a data scientist, we will work majorly on predictive and prescriptive. Descriptive we will do, but not like how the dashboard developers will do. So types of analytics we understood. Now, which are the systems that are available or tools available to perform machine learning or data science? We have like Python is one of the popular language, and any distributed machine learning model need to be developed. We use Hadoop or Spark. So both will help us to build a distributed ML model to go and build these ML models with a high volume of data with high velocity, and then high data like a huge data, high velocity, and also we will go and see how can we go and analyze this data with different varieties of data as well. So the system should help us to achieve all this. Apart from that, we also need to understand what is data mining. Also, data mining, as a data scientist, I should know what is data mining. Data mining is a process of analyze the data which is in the different formats and then summarize it into some meaningful, useful information. How can we go and extract that useful information? I can use that information which I received. I can increase the revenue or reduce the cost, or sometimes I can do both also. So by getting the insights from the team that the two missions will go down because of some defect failure. So we try to go reach out the vendor immediately and come and replace so that I will not experience any loss due to that. Ultimately, my revenue will be increased also. So data mining softwares available in the market, like Python example, is one of the tool that will help you to understand the data and analyze that. So there are so many packages available in Python to achieve this. And machine learning. So machine learning is also one of the area a data scientist or ML engineers should know. Like ML engineers majorly work on machine learning to of AI, which will provide the system or computer to learn without being explicitly programmed. Automatically it should learn. And automatically it should learn and it should go and allow us to predict the future. So ML model which we go and develop will be one of the model, and that will help you to predict the future if needed, or also it will help you to take some appropriate decisions about on the data side. So as a data scientist, I should know all these basic fundamentals. What is the data mining? What is machine learning? What types of machine learning is available? So we should know all this. So we are going to learn one by one as part of this particular training. And this is the domains where these are the domains which companies are using nowadays in the market as part of the data science activities. If you go and see healthcare side, you have so many use cases under data science and AI. So if you go and see healthcare like hospitals, so there are so many use cases, whatever you can see here. Medicare fraud is one of the very biggest challenge. And medical resource allocation, how optimally you can allocate the resources. And prioritizing the claims reviews. And also like patient survival analysis. So there are so many use cases under healthcare where you can go and build by using data science or AI. And we also have consumer financial, where credit card fraud is one of the biggest use case companies use to prevent the credit card fraud. And the construction domain, where contractor performance and design issue prediction, all these are the use cases, so that will help us to optimize the construction business of any company. And the travel domain is also one of the domain where people are extensively using for optimizing their like air traffic and also like seat and gate management also. So all these are the common use cases people are using in the market. And retail domain is also one of the very popular domain for data science. So inventory optimization, how to predict out of stock of a particular group of products in Walmart store. How we can predict in advance, maybe 1 week in advance, so that I can fill the products so that I will not experience a out of stock. And pricing optimization, how to go and optimize the price according to the time, like per item, per period, and per store. How can we do that? And with identifying which is the best place for the new store. And market basket analysis, this is one of the very common use case even we experience. You need to answer this question: how many times you visited a supermarket to buy one product, and you end up with full of basket? If I ask you, how many times when you visited, when your basket is full, even if you went to buy one product and you came back with full of basket, how many times it happened? I'm asking a question. How many times it happened to you? Shreya, or Bhanu or Chandana. How many times it happened to you when you go and to buy one product and you end up with full of basket?
Most of the times.
Most of the times, because
Yeah, many times.
many times the reason behind that is supermarket uses a market basket analysis process in the background. What they do as part of that process is they will try to find out which are the most recent products that bought as a combination. That can be two or more products, bread and milk. Correct, right? Like they also go and place products like chocolates and biscuits. You will find some products they keep together and they will add some discount also. That is basically they use this market basket analysis algorithm and they will feed the past transactions data, and in those transactions the algorithm will find out the most recent combinations which the customers bought. Diapers and wet wipes, correct, right? If you have a just one baby, people will buy that together. And beer and chips, so people buy together some products if you give some discount. Even if you buy, even in Amazon also will do that. Amazon, if you go to Amazon website, they will also keep on adding some recommendations, correct, right? The similar products. When you buy laptop, they will offer you charger or headphones, correct or not, everyone? How they are doing that? So they use this kind of algorithms. Market basket analysis is one of the algorithm people are using in supermarket business very extensively. So to increase the main objective of supermarket is to every customer who will come inside will should go with full of basket. Even I do that. I did many times. Even I know they use market basket analysis, but I forget about it. And I'll buy the products. I end up with full of basket. Because we are a human being. Whenever you see some kind of discount, we'll see like whether it is useful or not, we'll try to put in the basket. That is very quite common. So market basket analysis is one of the very popular ML algorithm which people are using in supermarket business. And manufacturing, which we discussed just now, how to find out the downtime of a machine, which machine will go down, whether this particular machine will go down or not, yes or no. How to optimize the quality of the product when you are manufacturing. Warranty analytics, which products of this particular machine are like going to defect, and which for those products, if they are under warranty, I'll immediately go and order them so that I will save some money. So this manufacturing domain, there is a warranty analytics domain, separate domain, where people work majorly to on the warranty analytics. And energy and utilities, we go to smart electric meters, how they are very smart to send messages to you whenever you reach a threshold. This is happen with the energy and utilities domain. And insurance domain is also very popular domain where data science people are using to predict the customer clients. How to go and optimize the price or increase the price so that the customer will buy the that particular insurance policy. How to optimize the agent and branch performance. That is about life insurance domain. And logistics domain, how to find out the best route to reach out the customer from source location, target location. Ola, Uber, most of this travel like cab services, they use route optimization to reduce the distance for the driver. And life sciences is the domain which data science people are using for a long time. They will use data science for drug discovery, identifying which drug is going to cure the disease, predicting the drug demand. So all these are very few use, like we can see there are so many other domains also. Real estate domain, house price prediction, predicting a house price based on the criteria like number of bedrooms, area of the house, age of the house, all this. And banking domain, like loan defaulters prediction. Or if you go to like cyber security, predicting the hackers so that we can prevent them before they hack. So there are so many domains. I worked on cyber security domain also, where my project was to predict malicious emails while people are registering. So the hackers also will come to register my product. So if I go and accept them, they will come and hack my website. So we need to predict the hackers and block them. So cybersecurity is very like a popular domain for data science nowadays, which has because I also work on I'm currently working on anti-money laundering team. So where my use case is to predict suspicious transactions, money laundering transactions in transaction monitoring of our bank transactions. So we can do that. There is a algorithm called anomaly detection we can use, and we can find out which are the anomaly transactions in my daily transactions group. So like that, we have so many use cases which a data scientist can help to the company with their business knowledge, technical knowledge, and ML knowledge and AI knowledge also. Are you getting everyone? Yes or no? Any questions till now from anyone on what we discussed about on data science and what is data science, what is the use of data science, and how we can understand how AI or data science can help to the company. As a data scientist, your responsibility is to help the enterprise companies to use their data and provide some recommendations so that they can take some appropriate actions out of that. Some insights you should provide, meaningful insights. That you insights can be anything, either predictions. You should predict which products are going to be best products so that they can invest more on that. You can help them to find out which is the best price for a product so that the customers will buy. You need to predict that. So most of these use cases will help you to increase every domain in that area. And as we discussed about, there are different tools available in the market for data science or AML. Python is one of the very popular language in the machine learning area, and Apache Spark and Hadoop also, they are also some of the popular ML tools in the distributed ML modeling. And data analysis, which you do as part of your data science activity, SQL, Excel, Power BI, and Python, all these four are very popular. Plus cloud tools like such as SageMaker, Azure ML, Azure Databricks, Azure Data Factory, Azure Data Lake Storage Generation 2. There are so many GCP like Vertex AI in Google side. All these are cloud tools. So I can implement my ML algorithm using these cloud tools as well. I can build my end-to-end data science project using all these tools. I can use my end-to-end data science project using SageMaker, which is a service in AWS. I can use Azure ML Studio to build my end-to-end ML project in Azure side. I can use Azure Databricks platform to build my end-to-end like a ML project. I can use Vertex AI to implement end-to-end. So there are so many tools, cloud tools also available in the market to achieve or build your data science projects end-to-end. And so if you go and see AI, ML, job market, education side, if you see, there are so many courses also coming into the market after data science became very famous. So many courses. So you might also seen so many masters courses and bachelor courses also are running in the market for data science perspective or AI and ML perspective. Masters in data science or masters in data analytics or business analytics. So there are so many courses which are already running in the market, and the degree wise you can see these are all the percentage which you can see as part of one of the survey. And programming languages wise, if you see, Python is on the top, and some people are using R programming also, but R became very down now, very obsolete now. Most of the people are using Python only. Very occasionally people are using Python in the data science area. Java also people are using, but very less. Compared to Python, Java is very behind in the data science side. And also trend wise, if you see, Python is on the top, and these are all the job offers which you can see by trend, by count. And Python is on the top, followed by data analytics and data science, and then machine learning. All these are required for most of the data scientists who are running in the market. And also you can see experience wise, there are so many like jobs which are available experience wise. If you see if you go and see the as a fresher, you will definitely can get some internships, but people always look for experience. So experience, if you have some experience, according to your experience, your like uh, jobs also will be more, and if experience increases, number of jobs also will be decreased. So we need to see. And coming to like technology side, in industries, if you see, technology is the topmost, is the 60%, and industrial, and then finance and healthcare also, they are balancing. So there are so many domains where data science is getting utilized in most of the areas. And also use cases wise, if you see, for example, in marketing side, you have so many use cases in marketing. Example, target advertising, how to go and target the customers by sending some advertisements. And then once the customer is ready, we can go and offer them the products. And also like customer segmentation, if we go and see telecom companies do customer segmentation of their customers, like gold customers, silver customers, bronze customers, they will try to group the customers, and then they will try to target them accordingly. If you are a gold customers, you will have high priority. And also like sentiment analysis, which is one of the area where people are using nowadays to understand the customer mind. They'll try to see whether customer is interested or not interested, and what is the customer insight, what is the customer mindset now. According to the tweet, I can go and find out whether customer is happy or unhappy. So there is a sentiment analysis use cases also available in machine learning to predict this. And predictive analytics and marketing budget optimization. There are so many areas where marketing domain also people are using this particular data science extensively. To learn data science, we definitely need to understand and go step by step. Basic Python we should start with, and also need to understand about the very basic fundamentals of statistics and probability, and followed by we move to advanced Python. And then once we finish advanced Python like pandas, numpy, we also will learn about matplotlib and cburn in the visualization area. And then we'll move into ML, visual learning algorithms, which are supervised and unsupervised. We'll learn, and we segregate and learn them. And then once after we finish that, we try to see how to manipulate the data by passing the data to these algorithms. And once you finalize, this is the ML model I need to use, we'll try to deploy them with different techniques. And as soon as you deploy your ML model, like the client will start using it. And once the client will start using it, your revenue start generating. When you are getting revenue means you also need to monitor the deployed ML models or data science projects as well. And also we learn about deep learning algorithms such as like artificial neural networks, convolutional neural networks, recurrent neural networks. All these algorithms we learn one by one. And then we also will learn a bit on NLP and generative AI also, which is going to help you for natural language understanding and natural language generation. And we'll go and learn them in detail with chatbots and LLM apps as well. So deployment side, we also will learn about some of the new like emerged hard skills in the market like MLOps. So we are going to learn about that also as part of this training, where you are as a data scientist, most of the people will stuck in how to deploy the ML model. So we are going to learn about in detail with use cases for every algorithm. We will try to learn with use case, with domain wise, and till deployment and monitoring also. So what is monitoring? Whenever you deploy any ML model, after deployment, you will experience so many issues. As a data scientist, you should know how to resolve them. It can be infrastructure, or it can be optimization, or it can be data side or model side. This kind of issues are very common. How you are going to address them is important. And for that, how to go and monitor which tools are important, we are going to learn as part of this particular training also. And after that, we'll also work on 4 or 5 end-to-end projects as well to like implement and explore what we learned till now. And finally, interview preparation, I will guide like what CV preparation and what interview in general interview questions will be there and how to address them. I'll go and try to help the area. And apart from that, placement guidance I'll give, not like placement assurance. All the course materials, daily class recordings, and assignments will be provided in the Google Drive, where you will go and access on a daily basis, day-wise. And interview guidance and the CV help I'll provide. Any mock interviews, if you feel you want it, I'll also take up some mock interviews as well. And I provide interview questions which are most frequently asked, which I ask in interviews. I'll provide, and few other interview questions I collected, I'll share you. And this is a 45 to 60 days, I can say, end-to-end training, and where you get a full-time data science end-to-end implementation knowledge, and you can prepare your CV accordingly and start your job trials as well. Okay, that's what about this training and all. And any questions now you can ask.